Hey guys, so this is just a quick video to help out with some of the most missed questions on the most recent homework. So please take notes, follow along, it should be very quick. This week's homework had a lot of focus on first and second fundamental theorem. One of the questions that a lot of students seem to miss was a question that was f of x is equal to the integral from -2 to cosine of x of 3t dt. Now, if the question was just asking us to evaluate this, like find what f of x is equal to, then we would take the normal integral. So we would get, for example, 3t squared over 2. That's the integral of 3t. There would be a plus c, but we'd be evaluating this from -2 to cosine of x. And then all you would do is plug in the cosine of x anywhere you had that t. So you would get 3/2 cosine of x squared, our top bound gets plugged in first, minus 3/2 -2 squared, our bottom bound gets plugged in next. Okay, this problem, however, is slightly different because for this problem, it's not asking us to just evaluate. So again, if we have f of x is equal to -2 cosine of x of 3t dt, the question a lot of you missed was when it asked us to find f prime of x, which means the derivative. If we're finding the derivative, that means we're finding second FTC. First FTC is what we just did. Second FTC is when you're taking a derivative of an integral. When that's the case, the idea here is that you're plugging in this bound, you're plugging in this bound in for this variable, and then multiplying by its derivative, and then subtracting, plugging in this bound again into that variable and multiplying by the derivative. The dt goes away, the integral goes away. What you end up getting here is 3 times cosine of x. So again, we're just plugging this in for any t's within this function. And then we have to remember to multiply by the derivative of our bound. So we're going to multiply by, in this case, negative sine of x. We're going to subtract, plugging in the bottom bound in for our function, so 3 times -2, right? Again, we're plugging it in for 3t, it goes in for the variable, except on this one, when I multiply by the derivative, we're multiplying by 0, which means that entire second term goes away, and our final answer is we would probably move this negative all the way out in front, and we would get -3 cosine x times sine x. Okay, we're just going to do one more example that's essentially the same idea. On this problem, if we are given f of x is equal to the integral from 0 to x squared of sine of t dt. Again, if it just asks you to evaluate this, which it might, then what you would need to do is you would need to actually take the integral and then plug in the bounds. So that's first FTC. If you have a bounded integral, take the antiderivative and then plug those in. On this question, however, we're doing second FTC. It asks us to take the derivative. So we're taking the derivative of the integral. And what that means is we're going to take this function, sine of t, and for anywhere you see a t, you're going to plug in your bounds and multiply by their derivatives. So that means we're going to get sine of x squared times 2x, and then minus sine of 0, but again, the derivative of 0 is 0, so that whole part goes away. Final answer is 2x times sine of x squared. That's it.